Look up tonight. Gaze into the inky blackness, past the city lights, and let your eyes adjust. You will see stars. You might see a planet, or the familiar face of our moon. It all looks so vast, so silent, so profoundly empty. This vision of an endless, serene cosmos is a beautiful illusion. The truth is that seemingly peaceful void just above our heads is becoming a crowded place, chaotic and dangerous. It's a cosmic traffic jam, a superhighway of our own making, and the risks of a major pileup are growing every single day. We have filled the space around our world with our ambitions, our tools, and our trash. If we don't manage this traffic, we risk losing access to this final frontier and compromising the tech that runs our modern world. Space just above our atmosphere is not boundless. It's a finite resource with specific orbital paths, like lanes on a highway. When we think of space, we imagine infinite distance, light years between stars. But the space of our traffic jam is surprisingly close and confined. This is low Earth orbit, LEO, about 160 to 2,000 kilometers above the surface. Here fly the International Space Station, Starlink and other constellations, and Earth observation satellites. It's the most accessible, and therefore the most valuable, orbital region. Since Sputnik in 1957, humanity has been sending objects into orbit, from one rocket and one satellite to dozens per launch. The exponential increase in launches is the primary driver. What was once an empty frontier is now a high-density environment, crowding, traffic, waste. Most tracked objects aren't active spacecraft. They're junk, defunct satellites, upper stages, and shrapnel, each a potential missile. The danger boils down to kinetic energy. In LEO, objects fly around 28,000 km range, nearly 8 km, about 10 times a rifle bullet. Because energy scales with the square of speed, even tiny mass can be catastrophic. A fleck of paint can hit like a bowling ball dropped from a roof. These are constant operational hazards for satellites and crews. Stations dodge debris, burning precious fuel and shortening life. A grapefruit-sized object at orbital speed has the energy of a ton of TNT. One smash can shatter a satellite into thousands of bullets. Every collision plants the seeds for the next. In 1978, NASA scientist Donald J. Kessler outlined a chilling scenario. If orbit gets dense enough, one impact could trigger a chain reaction. Junk could grow even if launches stopped. Some orbits could become unusable for generations. Imagine a rush-hour crash. Debris causes pileups and a standstill. In orbit, the cars move at 28,000 km/h, and no tow trucks come. The wreckage doesn't settle. It lingers for centuries. We haven't seen a runaway cascade, but we've seen precursors. The 2009 Iridium Cosmos collision raised large debris in LEO by about 10%. Those fragments will threaten for centuries. On February 10, 2009, high above the Siberian tundra, a working Iridium satellite and a defunct Russian Cosmos were on a collision course. Neither could maneuver. Their paths had crossed for years. That day, their closing speed exceeded 42,000 km/h. The impact was cataclysmic. Over 1,500 kilograms disintegrated in an instant. More than 2,300 trackable fragments, each a new threat. One of the most crowded regions of space was polluted further. Years later, debris from that single event still menaces, forcing ISS dodges. A costly validation of Kessler's warning, echoed by the 2007 ASAT test that created thousands more fragments. Space isn't just for astronauts, scientists, or billionaires. Our civilization runs on an invisible infrastructure of satellites. We don't notice them until they're gone. Space debris threatens stability, safety, and prosperity. GPS depends on at least 24 satellites broadcasting precise timing. Farmers plow, plant, and fertilize with centimeter accuracy, boosting yields and cutting waste. Markets rely on those same timing signals. A GPS disruption could cripple logistics, agriculture, and finance. Weather satellites track clouds, oceans, and atmosphere, warning of hurricanes and tornadoes. Live events, remote communications, and internet are routed through space. A cascade could bring widespread blackouts, grounding flights and stalling commerce. If space is messy, why not just clean it? Because it's one of the most daunting engineering challenges we face. Millions of fast, tiny objects spread across a huge volume. Matching orbits and velocity costs enormous energy, like catching a bullet with a bullet. Different orbital planes make it prohibitively expensive to chase many targets. Defunct satellites tumble unpredictably, hard to grab without damage. Sweeping small debris risks creating more debris if it's hit. Active debris removal is costly. Missions run into millions or billions. Who pays? The launching nation? The global community? The legal and economic questions are as complex as the technical ones. Cleanup isn't impossible, but it demands new tech and unprecedented international cooperation. Fixing this isn't a magic bullet, it's a multi-pronged strategy. We need global consensus and responsible stewardship from nations and companies. Design satellites to fully burn up on re-entry when feasible. In higher orbits, move defunct craft to graveyard orbits, far from active lanes. Make deorbit and graveyard rules enforceable, not suggestions. Invest in better tracking, ground radars, optics, and space-based sensors. Share data openly to warn and maneuver in time, space's air traffic control. Fund active debris removal to target the biggest risks. Explore lasers to subtly slow debris and hasten re-entry. A shared fund removing a few large objects each year can sharply cut collision risk. The cosmos is our canvas of exploration. Orbit is the gateway to the universe and vital to life on Earth. It has connected us, empowered economies, and saved lives. We must preserve this environment for ourselves and future generations. The solution isn't only technical, it's human. Space is a global commons. No nation owns it. All must protect it. Strengthen treaties, mandate design and disposal standards, prohibit destructive tests. The world is debating new norms, and companies are piloting solutions. We can learn to clean up after ourselves. The time to act is now. Each day we wait, the problem grows. And so does the risk of a cascade. This is our moment to choose.